Okay, buckle up because this might be a bumpy ride. We're given this diagram. This is what we're trying to prove. Notice that here we have three right triangles. The little one, the medium one, and the overall large one. Here's what I want to do. I want to make some markings here. So for sure this is a right angle. Now we have here, if I call this a single, I can put a double mark here. And it turns out, using properties from geometry, that this larger right triangle, if this is a single, that's a double. This would actually be a single, and this one would be a double. Now what I want to do is I want to draw the three triangles side by side by side by side. Maybe I'll do it in blue here. And what I want to do is maybe I can draw it right here. So let me draw the small one, and then I'll draw the medium one, and then I'll draw the large one, and I'll do it in such a way that the orientations are preserved. And I want them all to be a single, the right, and the double. So I want them all, I will force them all to have this orientation, and the letters and the vertices will have to go to the corresponding spots. So for example, if you're looking at the little guy, it's conveniently already looking the way it should. So this is B, C, H, X, little h, little a. For the medium here, I've sort of rotated it a little bit. So if you follow along, this should actually be C, this should be H, that should be A, and this here should be little h, this should actually be y, and this should be b. And for the larger one, if you apply the correct orientation from here to here, the larger one, it looks like this is going to be capital B, this is going to be capital A, and this is going to be C, where here, this is going to be A, and this one here should be B, and the hypotenuse is actually x plus y. Now recall properties of similar triangles and whatnot from geometry. These triangles are all similar, which means that they form sides that are proportional. For example, you could create an equation that says A is to H as B is to Y, or like X over H equals H over Y, or something like Y over B equals B over that, or for example, A over B equals this over that, and so on and so forth. You can do this all day. And I want to try this a couple of different ways, or I want to try two different things. Here's one statement or one connection that I want. I want one that says this. I want to go A over H equals this over that. So let's see, I want A over H, so I'll write it here. A is to H as that is to that. X plus Y, make that look like an X. So that's a true statement. This is a similarity statement and it's true from geometry. This is to this as this is to that. Why don't we cross multiply so that AB equals H times X plus Y, right? This times this equals that times that. And I feel like multiplying both sides by 2, what the heck? And I feel like distributing this. So 2AB equals 2XH plus 2YH. I distributed and I switched a couple of the variables, no big deal. So this here is a fact. And I actually want to establish another fact. And what other fact do I want to establish? How about this one here? How about, look, how about X is to H as H is to Y? And I'll do that in a different color. So how about this one? X is to H. So boom, 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 boom. H is to Y. And if I cross multiply, that'll say XY equals H squared. And I'll call this another fact. that I might use in just a moment. So again, this may seem random, but it's not. I'm gonna need these things. Now, why don't I apply the good old Pythagorean theorem? You see, I did this because I was motivated by looking at this here. I saw this, and I think that these facts are gonna come into play in just a moment. For now, let me use the Pythagorean theorem for the larger triangle, which says a squared plus b squared equals c squared. So here's what I have. I have here a squared plus b squared equals that squared. So a squared plus b squared equals, that's my c squared. Let me reverse the order, which is totally fine. And we know what it means to square something. It means to write it down twice and to expand it, which if I do so, I get this here. Like that, like this, like this, like that. And I did all that basic stuff there. Now watch what I do. Watch what I do. I'm gonna go like this, I'm gonna go like that, like this. So instead of xy here, instead of xy, I'm gonna use this fact that says xy is the same as h squared. So I'm gonna call this h squared. And then watch what I do. X squared plus, let's say h squared plus y squared plus h squared. So I ripped apart the 2h squared into 1h squared, 1h squared. So that's my 2 right there. I just did that. And watch, let me do something else here. Let me go like this. Let me go like this. Check this out. We're almost done, actually. Two more steps and we're finished. And then I'll make some closing remarks. Watch what I do here. So here's what I want to do. So these are the same thing, right? That's there, that's there, that's here, that's there. Those pieces are there. But I just opened up some brackets or some empty spaces. Now here's the equal sign. So whatever you introduce to the left, you must introduce to the right. So whatever I include here, those pieces must be the same as this piece, right? To keep this equation balanced. Here's where I want to use my fact number 1, where these two pieces added together equals that. So let me take these two pieces, drop them here, and to keep this balanced, here, I'm going to put that there because these two quantities are equal. So conveniently, let me drop the 2xh right here, the 2yh right there, and to keep it at equilibrium, the 2ab goes in there. And watch how this works. This here, that is the same as x plus h squared, right? Because if you expand this, that's what you get. Similarly, this trinomial happens to be the square of that binomial. Keep your addition operator the same, equals. And as you can probably predict it, that trinomial is the same as the square of that sum. And you know what I'm going to do? I am going to put a check mark because we're finished. Because what was the goal? The goal was this, to show that this is true, and we have. Is there an easier way of doing this? Maybe. I don't know. All I know is that I practiced on some scratch paper, and I sort of processed my thoughts, and it led to this demonstration. So you might find a faster way of doing this, I don't know, but this way that I've shown you is valid, and I hope you learned something from it. I hope you found it helpful and that it was hopefully legible. So if you have any questions, let me know.